Hey guys, it's Miss Manili. I'm going to be introducing Unit 2 by way of video this evening, and what I'd like you to do for your homework is simply take notes. I'm going to be introducing a lot of vocabulary terms. A lot of these terms, though, we've covered in Algebra 2, so you'll probably remember a lot of the terms. Many of them are very self-explanatory, and you'll probably intuitively understand what they mean. We spent Unit 1 analyzing data, where you were given data sets. Sometimes you had one variable, sometimes you had two, sometimes the variables were categorical, sometimes they were quantitative, and you learned all sorts of methods for displaying that data using graphs and then analyzing the data using number summaries. And so in the Unit 2, we actually sort of go backwards. Now that you have a good understanding of the different types of data that are available and the different types of things you can do with data, we're going to talk about how to actually collect data. So Unit 2 is all about methods for collecting data. And there are essentially two methods that we use. We have observational studies and we have experiments. Both are very important, but both have very, very different purposes. So in this first lesson, I'm going to be talking mostly about observational studies. So we're going to be defining a lot of terms like populations and samples, and then different types of sampling designs, ways to reduce bias. And then in our next lesson, we'll talk about experiments, and that's the other basic form of data collection. And then as we wrap things up, we'll talk about ways to make sure that we're using these studies wisely so that we can be confident in the results and the predictions that we want to make. So like I said, this first lesson, we're just going to talk mostly about samples and surveys, and specifically from an observational study. So the objectives today are simply to be able to define a population and a sample in a statistical study. There are several different sampling designs that lead to bias. For example, voluntary response and convenience samples are very common sampling designs that always lead to bias in your results and really are meaningless. You can't really do anything with the data that you get because it's not representative of the population. But like I said, they're very, very common designs. And then we'll talk about ways to fix it, how we can reduce bias in obtaining a representative sample by using randomization techniques. And there are several different types of really good sampling designs that we'll talk about. Some of them you may remember: simple random sample, stratified samples, cluster samples, systematic samples. These are all samples that reduce the bias in the selection process. We'll also talk about other types of bias, though, that can still contaminate your data and make it meaningless and difficult to analyze. And that would be like undercoverage, non-response, the way a question is worded. You may remember some of this from Algebra 2, like I said, but we'll go over it again. So tonight's lesson, your homework is simply to watch the video and take notes so that when you come in next class, you're good to go with all these definitions. So like I said, there are essentially two types of data collection methods. We have observational studies and experiments. And the purpose of each of these is very, very different. In an observational study, we are interested in making generalizations about a population. Or a population of interest, I'll say. So I'm a teacher at Southern High School. I teach teenagers. You know, maybe I'm interested in what their thoughts are about the selection process. So maybe I ask questions about, if you could vote, who would you vote for? Do you lean to the left? Do you lean to the right? Are you more moderate? Maybe these are questions that I'd want answered from students at the school. So if I ask these questions and get this information, I'm probably not going to be able to interview everyone at the school, so I'll probably just select several students and then gather information from those students and make generalizations about the population of students at Southern High School. There are lots of things I have to be careful of when I do that. And we'll talk more specifically about that later on in the lesson. But an observational study is essentially where you're observing behaviors of subjects or gathering information from subjects that already exists. So I'm just trying to tease out opinions or understand something about the population that's already in existence. I'm not looking to change anybody's mind. I just want to know how people feel or how they think about a certain subject. These are observational studies. A controlled experiment, my goal is to understand cause and effect. My goal is to kind of prove that one thing causes a reaction in another. And that's my purpose. That's the purpose of doing an experiment. So in the study, a researcher imposes what we call a treatment on the subjects and then observes their response. So if I wanted to, understand the benefit of maybe study sessions for the AP exam, I might break my class into two groups and have half the class not receive extra study sessions and have the other half of my group receive study sessions and then compare their performance on the exam to see if there's a difference. And if I have controlled all the other variables that may lead to differences in their scores, then I can conclude that the help sessions actually were responsible for the difference that I see. And again, we'll talk about all of the elements of a good, well-designed experiment when we get to that section. But with an observational study, I'm really just observing. I'm trying to get information that already exists. I can look at medical records. I can do interviews, questionnaires. Whereas in a controlled experiment, I'm actually imposing a treatment, and people are responding to the treatment so I can gauge their reaction. We're going to focus today's lesson on observational studies. So some examples would be an opinion poll wants to know the fraction of the public, or what fraction of the public approves the president's performance in office. Or a quality engineer wants to estimate the fraction of bearings rolling off an assembly line that are defective. A government economist inquires about the household income. In all of these situations, we're just gathering information about a large group of people or things without really changing anybody's mind. We're just looking for the information that already exists. The problem is time, cost, inconvenience would make it very difficult for me to interview everyone or to inspect every bearing coming off the assembly line. So in such cases, instead of talking to everyone in my population, I would simply gather information from a part of the group in order to draw conclusions about the whole. And that really is the purpose of an observational study. So in a statistical study, here's some definitions for you. In a statistical study, the entire group of individuals that we want information about is called the population. Sometimes they're referred to as subjects in an experiment. Individuals don't necessarily have to be people. They could be the ball bearings that are coming off an assembly line. They could be rats in a cage. Individuals are simply the things that we're gathering information about. A census is a type of observational study in which the researcher gathers information from every individual in the population. The United States does a census every 10 years, but it's not perfect. It's not actually a perfect census because it's very difficult to identify every single individual that lives in the United States or that is considered a resident of the United States. You've got people that travel abroad. You've got soldiers that are deployed in other countries. You've got renters that are very hard to identify, and the homeless population is also very hard to account for. So a census, the goal is to identify every single individual in a population, but that's very, very difficult to do. So what we do is we identify a sample, which is a subset of the individuals in the population from which we actually collect data. And so this next slide is simply just a graphic. So we've got our population, which includes everyone, but we can't actually interview everyone, so we interview a sample of individuals. So we collect data from what we hope is a representative sample, and that's very, very important. We want to make sure that if I'm taking an interview of a small group of people from a population, that the people that I'm interviewing represent the population fairly. So for example, if I've got a class of students where I've got half male and half female, and I take a sample where 2/3 of my sample is male, that's not going to be a representative sample. The same would be true for other demographic information too, for example, race and ethnicity. So the idea is that if we have a representative sample, then we'll be able to make inferences about a population. Inference is another really important part of this course, and it's actually really the purpose of all of this research, is to take information that we have and make generalizations that kind of go beyond our data. So in an observational study, if I'm looking at a sample, I would want to make inferences about the population, and that would be generalizations about the population. If I'm doing an experiment, the inferences that I would make would deal with cause and effect. So inference is a really big part of this course. In fact, the second semester is dedicated to inference and using statistical procedures to determine or to make inferences. Okay, so in this example, we have you have two situations, and you're asked to identify the population and the sample in each. I'd like you to go ahead and pause the video and go ahead and write down the population for each situation as well as the sample. And be as specific as possible when you're defining the population. Okay, so in letter A, it says the student government at a high school surveys 100 students at the school to get their opinions about a change in the bell schedule. The population, I'm sure you guys recognize, is going to be all the students at the high school. But I think you need to be a little bit more specific than that. We want to make sure that we're talking about all the students. Are we talking about the ones that are simply present on a single day, or are we talking about all of the students that are enrolled in the high school? And so you want to be specific. So let's say our population then would be all students currently enrolled. And then my sample would simply be the 100 students who were selected to complete the survey. In the next one, it says the quality control manager at a bottling company selects a sample of 10 cans from the production line every hour to see whether the volume of the soda is within acceptable limits. There's two ways you can look at this problem. Since we're kind of narrowing it down to every hour, I would define the population as all cans produced on the assembly line each hour. Or I guess this is the production line, not the assembly line. And then our sample would be the 10 cans selected each hour for review. You could also look at this as more of a big picture and say that the population represents all of the cans that are produced by the bottling company, and then the sample would be the 10 cans that are selected each hour for review. But the idea here is that you understand the difference between the population and the smaller subset or the sample. Okay, so the idea of a sample survey. We often draw conclusions about a whole population on the basis of a sample. A type of observational study in which the researcher gathers data by asking for responses from subjects in a sample is called a sample survey. Pretty self-explanatory. Choosing a sample from a large varied population, though, is not easy. And the first step really is to define the population that you want to describe. And that is not as easy said as done. So for example, again, if I'm talking about the students enrolled, or I'm sorry, if I'm talking about the population of students at Southern High School, I might want to be very clear about who I am including in that population. Is it students that are present on a certain day, or is it students that are currently enrolled in the school? And when does the enrollment start? Do I want to look at the students that were enrolled on the first day of school? Or maybe am I only looking at the students that were enrolled on the last day of school? And it kind of depends on what I'm measuring. So for example, if I'm looking at discipline data and I'm a principal and I want my school to look good, I may be more interested in the population of students at the very end of the year if I was able to find like alternative placements for some students so that doesn't get held against me. So you do want to be kind of clear on who your population is and when you're accounting them. The second step is to define exactly what it is that you want to measure. And a sample survey is basically a study that uses an organized plan to choose a sample that represents some specific population. And we're going to actually, our first project is actually going to be to conduct a sample survey. You guys are going to create a questionnaire and you are going to identify a population of students at Southern and select a random sample from that group to share your survey and collect data. Once you collect the data, then you're going to use all of the methods from our first unit to actually to construct graphs and draw conclusions about that group of individuals. And we'll get into that a little bit later. But it's important that you decide how you want to sample from the population. So let's talk about what we call the sampling design. The sampling design, or the sampling method, refers to the method that we use to choose a sample from a population. You guys might remember this from Algebra 2. Again, we really want to make sure that when we are choosing a sample that it is representative of the population. Because if it doesn't represent the population, then I can't really make any generalizations or inferences based on the data that I have. So our goal is to make sure that our sample represents the population fairly. And the biggest barrier to that is what we call bias. And there's two different types of bias. Bias can occur in our selection process. So when I'm choosing individuals to be part of my sample, I can introduce bias that way, and that means that I end up with a sample that's not representative of the population. But bias can also be introduced when individuals respond to the survey if their responses are influenced in some way. And so we call that response bias. So there are ways of reducing selection bias and response bias, but sometimes it's not possible to eliminate it entirely. Okay, so let's talk about selection bias, bias that occurs in our sampling technique. There are two primary types of selection bias, and that is what we call a convenience sample or a voluntary response sample. And these are probably the most common types of sampling designs that you see or read about. A convenience sample, this is students' favorite sampling technique. A convenience sample is basically when you choose individuals in a population who are easy to reach. So, for example, if let's say I work for the airlines and I'm interested in customer satisfaction, but I'm only interviewing customers or individuals that come off flights for Southwest, and I'm not really looking at Delta or American Airlines, and I'm only looking at passengers at one airline or one airport, that would be a convenience sample. If students, this is something that students commonly do, if you have to conduct a survey, who are you going to ask? You're going to ask your friends to complete it. You're going to ask the people that are closest to you, that are easiest to reach. This is what we call a convenience sample. And we really can't be confident in any of the results that we get, because a convenience sample most certainly is not going to be representative of the population at large. The other kind of sampling technique that is really, really common on the radio, on the internet, on TV, is what is called a voluntary response sample. And this is basically when people choose to be part of a sample. So, for example, if you're listening to the radio and a DJ poses a question and says, hey, everybody who's interested in earlier school start times, we want to know how you feel. Give us a call and tell us. American Idol, that's voluntary response. People are choosing whether or not to be part of the of the sample, and that is obviously going to be selection bias, and it's going to yield a sample that does not necessarily represent the population. And oftentimes when you pose a question to people, the people that tend to respond are the ones that are really passionate about the subject, and oftentimes it's those that have a really negative opinion. It's not all the time. I don't want you to think that every time there's a voluntary response sample that it's a bunch of angry people calling in, but very often the people that respond to these kinds of surveys tend to be very passionate, have very negative opinions about things, and they want their voice heard. So these are the two types of sampling methods that are very biased. They're very common, so you want to, when you read research, you do want to kind of pay attention to how the sample was conducted. If it's something like on the internet, think about like Facebook quizzes, or Entertainment Tonight does audience viewer polls all the time. If you go to CNN, if you go to CNN's website, they'll have polls that people who visit their website complete. These are all voluntary response samples and aren't representative of the entire population. The types of bias that can be produced from the response, so even if you have a great representative sample, you can still screw it up up with response bias. So there are several different types. Undercoverage bias. This is essentially exactly what it says. It's when some portion of the population is not sampled at all or has a smaller representation in the sample than in the population. And some of these types of bias kind of go together. If I'm doing a voluntary response sample and I'm a DJ, for example, and I'm calling out to listeners to call in and to answer a certain question, well, anybody who's not listening to the radio station is not going to know to call in, so they're not going to be covered as part of, they're part of the population that's not being covered. So we call them under coverage. So sometimes the sampling design itself leads to other types of bias. In the census, for example, like I said before, the homeless population often is underrepresented in the census, or renters are often underrepresented in the census, even though we're supposed to collect information about everyone. Non-response bias is another type of situation. It's a little bit different from undercoverage. It's basically when those who have been chosen, so if you have selected a sample and you've identified the individuals that you want to complete a survey, but there are some people who simply won't complete it or don't submit it, that's what we call non-response. So when those who do not respond to the survey differ from those who do. It occurs when people who have been chosen for a sample choose not to participate. So I don't know if you guys ever have to call the bank or call your cell phone company. Very often they'll do market research questionnaires at the end of the call. And so they'll ask, are you willing to participate in a survey at the end of the call? And you can say yes or no. Well, if they're asking, that's because you've been selected. So if you decline, that creates non-response bias. The other type of bias is called response bias. It's very, very general, and it's not the opposite of non-response bias. Response bias is basically anything in your survey design that may influence responses. It can happen in lots and lots and lots of different ways. If I am doing a face-to-face interview and I'm asking really sensitive questions, people may not feel comfortable being completely honest with me. So if I'm asking teenagers questions about, their activities on the weekend, and I ask them maybe about, drug or alcohol use, they may not be comfortable answering those questions to me face to face. And so I may not get authentic answers, and that would be considered response bias. A way to avoid that would be to do an anonymous questionnaire where students could answer honestly without me knowing who it was that responded. Other types of response bias, it could include just my presence. I'm of course drawing a blank, but we'll look at a lot of examples where you'll be able to identify the response bias. Wording effect bias. It would be, an example would be if the wording of a question is really poor, if it's confusing, if it's leading, if I give you information and then ask your opinion about something, where the information that I'm providing may change your mind about something, then wording effect. The way I word a question can certainly affect your response. Or maybe it's a multiple choice situation, but none of the answer choices match your actual opinion, so you have to choose something that's not authentic. That's going to lead to bias. I just thought of another example of response bias. Speaking of the election, so like if I was walking around with a Donald Trump t-shirt on and asking you your opinions about the election, even if it wasn't super sensitive, you may be uncomfortable telling me that you're a Hillary supporter if I'm wearing a Trump, or maybe you wouldn't, but it certainly may influence your honesty and your responses if I'm present and asking questions and my opinion is sort of known. Okay, so how can we reduce at least sampling bias? So randomization is this is how we reduce selection bias. Because remember, we want a representative sample. And one way to do that is through randomization. But in order to be random, I have to be able to articulate everybody in the population, and that's not always an easy thing. So randomization is the best defense, again, against selection bias. Even if I have a random sample, if I ask personal questions directly to students that they're not comfortable answering, then I'm still going to get response bias. But randomization will limit, it doesn't eliminate bias, but it does limit bias. So we want to make sure that we're selecting our sample from our population randomly. Random selection eliminates bias in the choice of a sample from a list of the population. Randomizing makes sure that on average the sample looks like the rest of the population, and that's what we're calling representative. Okay. So, for example, I used to teach at Annapolis High School. And at Annapolis High School, when I was there, roughly 40% of the student population was Caucasian, 40% was African American, and 20% was Hispanic. So if I were taking a sample of 100 students, I would expect there to be about 40 African American students, 40 Caucasian students, and 40 Latino or Hispanic students, or I'm sorry, 20 Hispanic students. And that would be representative. So, randomization isn't always going to guarantee that I'm going to get those proportions, so there are actually some other methods that we can use that also will produce a representative sample. So a simple random sample is probably like the ideal sampling design, but it's not always possible. It's not very easy to do. A simple random sample, the purest form would be to put everybody's name in a hat and then to draw names randomly from the hat. Individuals are selected, and there are two criteria. Each individual and all possible combinations of individuals are equally likely to be in the same sample. So every person has the same chance of being selected, and every possible combination of sample has the same chance of being selected. And that is what we call a simple random sample. And again, the purest way to do that is to put all the names in a hat and then to draw the names blindly from the hat. But it's not always easy to identify everyone in a population. So an alternative would be to do a systematic random sample. So think about systematic, a system or a rule. So the first individual is chosen at random, and then a system or rule is used to choose all other individuals. So an example of this would be, let's say I am working at the airline and I'm interested in doing a systematic random sample of passengers from a single plane. So I might go ahead and choose the first person and then every fifth person that deboards the plane to be part of my sample. When it talks about the first individual being chosen at random, another example would be if I've got a phone book. I might choose my very first person simply by randomly selecting a page in the book and then a name on the page, and then choosing every 100 names or every 100th name in the book. And once I get through the Z's, I'd go back to the A's until I made a complete loop of the entire phone book. And that's how I would determine my systematic random sample. So systematic is like a rule that you follow. But again, it eliminates the choice in the sample, and so it reduces the selection bias. Stratified and cluster random samples are very similar, and they're the sampling designs that students tend to confuse. Both designs require that we break a population down into subgroups. With a stratified random sample, I will take a random sample from each of the subgroups, whereas a cluster sample, I'm going to take a random sample of subgroups. So I'll give you an example. So let's say I have a classroom. I'm just going to draw X's to show the rows. So these are rows of desks in a classroom. Okay, so, oops. Let's see. Let's group them, and then I want to clone them. Okay, so if I am doing a cluster, okay, I might say, all right, I'm going to break my population down into subgroups by row. And then from there, I am going to randomly select one person from each row. And if I'm doing this randomly, the names that I've circled will be the students in my group, and that is considered a stratified random sample. A cluster, so this is stratified. A cluster starts off the same way. I break my population down into groups. And so maybe I label this 1, 2, 3, and 4, and I then I randomly select one of the groups. And so every individual in that small group becomes part of my sample. And so that's what a cluster means. It would be a group of groups. And it doesn't have to be one group. I could randomly sample two groups from the population. If I'm dealing with like students at Southern High School, I might break everybody down by advisory. A stratified random sample would be as if I had teachers randomly select 2 students from each advisory, and then those 2 students from each of the groups be part of my larger sample. A cluster would be if I randomly selected 10 teachers and had everyone in their advisory be part of my sample. But students often get them confused because they basically refer to breaking the population down into groups. And then the last type of sampling technique, sometimes you'll see this in the course, it's not something that's really covered very much in your book, would be a multi-stage random sample. This is for large research. If you're interested, for example, in knowing opinions of everyone in the United States, it's going to be really hard to identify the entire population and then randomly select. So oftentimes what we do is we break it down. So we break it down by state and then maybe by zip code or by county in the state. So a multi-stage random sample involves several different sampling techniques. Where we randomly select several groups from a population, and then within each group we randomly select a subgroup, and then within each subgroup we randomly select individuals for the sample. So it's usually a combination of stratified, cluster, and simple random samples. Like I said, we don't really spend a lot of time talking about multi-stage samples in this course, but it is a type of design. So let's see. I'm going to quickly go through. Well, actually, you know what? What I'd like you guys to do, there are 4 examples here of different sampling techniques. What I'd like you to do is pause the video and see if you can identify the sampling design. And then I'll show you how to do number 2, where we actually use a table of random numbers to select a random sample. So please pause the video and complete problems 1 through 4. Okay, so I've gone ahead and I've placed the answers on the board for you. The first one is systematic because we're choosing every 5th person on a list. Number 2 is the purest way to conduct a simple random sample by placing all the names in a hat and then blindly drawing names. 3 and 4 are similar in that everybody's been broken down into different groups. So in number 3, we've grouped students by their class, freshmen, sophomores, juniors, and seniors. But we're choosing a simple random sample from each grade level. That's stratified. So each grade level is represented. In number 4, though, we're assuming every student has a math course. So that's what we call our strata. We've divided everybody by their math class. But this time I'm randomly choosing one math teacher and using all of the students in that teacher's classes. So that is what we call a cluster. So notice not every math course is represented. Okay, the last thing I want to show you is how to choose a simple random sample. I don't expect everyone to take a population, cut up all the names and put them in a hat and draw the list from there. Computer software will often create a list of for example, like my smartboard has a way of me importing names of students, and then it will actually draw names randomly. So a lot of computers have the ability to draw names randomly for a sample. But I'm going to show you how you're going to end up doing it. So again, the first thing you really need to do is identify the entire population. So identify each individual in the population and give them some distinct numerical label. You want to make sure that if you're going to be using a table of random digits, which I'm going to show you how to do in a second, you want to make sure that all of the digits are the same length. So if you have 100 people in your population, you want to make sure that every individual has a 3-digit number. If you have 1,000 individuals in your population, then everyone will need a 4-digit number. Even number 1, that person's number will actually be 0001. And that's important if you're using a table of random digits. It's not as important when you're using technology. And you'll see what I mean in just a minute. After you've given everybody a label, then you actually look at a table of random digits. You pick a place to start, and then you just start looking at digits. The easiest way for me to do this would just be to go ahead and give you an example. So here is a list of hotels at a popular tropical vacation spot. There's 28 hotels. And I want to choose a list of 4 hotels. Now you also have attached to your notes a table of random digits. This table will be provided to you on the AP exam. So it's something that's provided. It's in the back of your book. And so basically this is just, imagine putting 10 slips of paper in a hat, 0 through 9, and drawing numbers and creating a table of all the numbers that you draw. That's exactly what this is. And so we're given instructions to begin at line 130. So if I look at line 130 on my paper, you can see it starts just like this, 69051. So all I did is I just transferred the numbers onto the smartboard so I could do this all on one page. So if I want to select 4 hotels, notice since there are 28 hotels, everybody has a 2-digit number. And what I'm going to do is I'm going to start at the beginning of my line and I'm going to look at 2 digits at a time. And so notice they're grouped by 5 digits. So my next group will be that 16, 48, 17. So right now I am just separating and then I'm just going to look at 2 digits at a time, and I'm going to circle the hotel that is going to be part of my sample. So I look at 69 and I can see I don't have any hotels that are labeled 69, but I do have a hotel that's labeled 05. So that means the Beach Castle Hotel is going to be selected for my sample. The next one is 16, and that also corresponds to one of my labels. That means the Radisson is going to be selected. 48 is not on my list, but 17 is. So that means the Ramada is going to be included in my sample. 87 is not. 17 I've already chosen, so I'm going to ignore it and move to the next pair of digits. 40 is not on my list. 95, 17 again. That's funny. 84, 53, 40, 64, 89, 87, 20. So 20 is on my list, and that I believe is the 4th hotel that I need. And so I've got the 4 hotels that I'm choosing for my simple random sample. I'll show you also how you can use your calculator, the random integer generator on your calculator, to also choose random samples, but I'll show you that at another time. Okay, so in this lesson, basically, we went through different types of sampling techniques, different types of bias. One thing that we also want to talk about is what we call sampling variability. Sometimes it's referred to as sampling error, but it's not a mistake. In fact, it's not a problem at all. Sampling variability or sampling error is always present. So if you think about it, if I am interested in election opinions from students at Southern High School, and I take a random sample of 20 students and I get their opinions about the election, if I were to do that same thing over again and collect another sample, I'm going to have different students in my sample, and they're going to have different responses. And I can do this over and over and over again, and I know that each sample is going to produce different answers. It's not a problem for me, though. Those differences that I see are what we call sampling variability. One way that we can reduce the variability is to make sure that we have large samples. If I'm sampling from two people out of the population of all of Southern High School, I'm going to have a lot of variability between my responses. But if I'm taking samples of, say, 50 students, and maybe I'm interested in the proportion that are Democrats versus the proportion that are Republicans or independent, I'm going to see less of a difference in those proportions the larger the sample I draw. So every sample is going to produce different data, and I know that going in. So there are certain things that I can do to reduce sampling error, and one of them would be to make sure that I'm taking a large enough sample. But sampling error is not the same as bias. Bias is a systematic difference from the true value. It's a systematic favoring of one outcome, whereas sampling variability or sampling error is just the tendency for my sample results to be different. And it's normal and natural, and it's not a problem at all. Inference for sampling. The purpose of a sample is to give us information about a larger population. The process of drawing conclusions about a population on the basis of sample data is what we call inference. This is a very major part of this course, is to be able to make inferences about a population based on a sample. So why should we rely on random sampling? Well, it avoids bias in the selection of samples when we have a list of available individuals. And the laws of probability allow trustworthy inference about a population when the results come from a random sample. We'll have what we call a margin of error, and that margin of error kind of describes the sampling variability. It includes the sampling variability and like the standard deviation, but it kind of accounts for the differences that we see in the different groups of individuals we come in contact with. And the larger random samples are going to give us better information about the population than smaller samples. It would also reduce what we call the margin of error. In fact, with all of the polls that are going on nowadays, you might see something where like, Clinton is leading the polls, 53% with a margin of error of 4%. Well, if you think about that margin of error, it means that there's enough variability in the responses that she could have 53% favoritism, or maybe it's as low as 49 if we subtract the 4%. Or if we add the 4%, maybe it's as much as 57% favoritism. But we understand that any estimate I make on a single sample is going to be different if I collect a different sample. So oftentimes we have our estimate, and then we also report what is called a margin of error. And so sometimes you'll see like a plus or minus symbol. Sometimes margin of error is represented as a percentage. Sometimes it's represented as a number. And you'll see it more often now that we've talked about it. But to kind of wrap things up, I've got an example here. It says in May 2010, the Los Angeles City Council voted to ban most travel and contracts with the state of Arizona to protest Arizona's new immigration enforcement law. The Los Angeles Times conducted an online poll that asked whether the City Council was right to pass a boycott of Arizona. The results showed that 96% of the 41,068 people in the sample said no. Well, what type of sample did the Times use in this poll? It was an online poll that simply asked a question. They did not select their sample. So if you think about the individuals who responded, they selected themselves. This is what we call a voluntary response sample. And again, very often the people that respond to these kinds of surveys are very, very passionate about the topic. And so in question B, or in part B, it says explain how the sampling method could lead to bias in the poll results. Well, first of all, we're going to have undercoverage. Remember, that was another type of bias. If you think about it, if this is the Los Angeles Times conducting an online poll, I'm assuming they're doing it on their own website. So it's people who didn't see the poll, or know how to respond. So people without internet access, for example, might not be able to respond to this poll. They wouldn't even know, but that doesn't mean that they don't have an opinion about it, and their opinion may be different from those who did respond. So undercoverage would be one example of bias here. The other would be, very often in a voluntary response sample, like we said, people with negative opinions are often overrepresented. And I think you can see here with the 96% of the students responding no. All right, so just to sort of wrap things up, you should at this point be able to identify a population and sample in a statistical study, identify the sampling methods to determine which ones are biased and which ones are random. You should also be able to identify the different types of bias, whether it's selection bias or response bias. And what I'd like you to do just to kind of finish up the homework is the practice examples, problems 3, 4, and 5. And so your homework is basically just completing these notes and submitting them next class.